Welcome to Axelent Safety webinars. This time we deal with choices that every machinery and system designer has to make. Safeguarded areas need openings for entry and exit of goods, to insert parts, or maybe just for maintenance access. But such openings, of course, could compromise safety during operation. Therefore, they have to be covered somehow. Such covers could be fixed, hinged, monitored, or locked. We will now discuss the requirements for openings in guard fencing, the criteria for the choice of a fixed or a movable guard, the functions of monitoring, so-called interlocking, and finally, when to choose guard locking. Most openings in guard fencing are not for people, but for goods or parts. Raw materials must enter, finished goods must exit the machine. Thus the openings are often close to a conveying system. Fortunately, such a permanent opening can be misused. Somebody might reach into a hazard zone while the machine is running, for instance to solve a small problem. But you may wonder, what reasonable person would crawl into a dangerous machine while it is operating? Well, the simple reason might be that it saves him a lot of time and trouble. He wants to fix a little problem, and it would take a long detour to go and open some door, walk up to that space, then fix the problem, return, close the door, reset and start the system. Also, stopping some systems might cause fault parts and a lot of waste thereby. It might need a lot of time to properly reset and restart the system, so people take a shortcut. But of course, such misuse of openings is very dangerous and must be prevented. How can we do that? The most important measure is to keep entry and exit openings as small as possible. It should not be possible for operators to reach into the opening with a body part larger than a hand or arm. Additionally, ensure that no hazard is within arm's reach. This extract from ISO 13857 shows that 120 mm is a limit you want to keep in mind. Ensure there is no larger gap than 120 mm between a wall and a guard fence or between fence sections. If there is a larger gap, close it with a fixed or adjustable infill. The maximum size of a slotted or rectangular opening is 120 by 240 mm. Since an opening that is larger than 40 by 65 mm allows a hand and thus an arm to pass, any hazard must be a minimum of 850 mm away from the opening. That is the arm reach. ISO 13857 adds two important notes. Slotted openings larger than 120 mm may need an even larger safety distance, and rectangular openings larger than 180 mm or square openings exceeding 240 by 240 mm allow the entire body to pass. That applies not just to contortionists. Some people are quite small and skinny and might be able to crawl through such an opening. At this point, I can almost hear some of you say, "Isn't this taking the thing a bit too far?" I mean, after all, somebody who crawls into a dangerous machine does so deliberately, knowing that there is a hazard. Shouldn't it be enough to fix a warning sign there to keep him from doing that? Well, that's a half-truth at best. because machinery safety standards require that we take 2 other steps before we decide for a warning. First, we should try to remove the hazard altogether. We call that inherently safe design. If that is not possible, then we need to add safeguards. That could be a fixed or movable guard, a monitoring function, or some kind of manual control function. And also please remember that sometimes people do not deliberately enter a hazard zone through an opening. They might slip, stumble, and fall, and then reach with body parts into the opening. But what if you need a bigger opening? What can we do? There are different options. For one, you can add an entry or exit tunnel. It must be at least 850 mm long, the arm reach length. You may also add a light barrier in a tunnel to monitor access. Of course, it needs to be muted when parts enter or products exit. Or you may install an automatic door with contact bar and safety switch. Whatever measure you choose, be sure to add a warning sign also. Openings that are not permanently needed during operation for entry and exit of goods should be covered. Normally what we use is a removable sort of cover called a fixed guard that can be removed for maintenance but normally stays in place. If access is needed more frequently, then a lid, a shiftable cover, or a door with hinges is the better solution. These are called movable guards in standards. But when to use which? When do you opt for a fixed guard, and when do you use a movable guard? Let's look at this topic next. When deciding for a fixed or movable guard, consider 3 factors: the need for access, the type of work to be done during access, and the frequency of access. To make the decision, ask 3 questions. 1. Will access to the hazard zone be needed at all? If the answer is no, a fixed guard without any interlocking is sufficient. The machine will have to be shut down before such a guard is removed. If the answer is yes, a second question must be asked. Will access be needed during operation, for instance to insert parts, check things, or resolve frequent faults? If the answer is yes, a movable guard with interlocking must be used. Interlocking means that the machine stops when the guard is opened and cannot be started as long as the guard is open. Why is that necessary? There are 2 reasons. It is likely that a fixed guard that needs to be removed often will not be fastened properly every time. In many cases, it will not even be reinstalled at all. Without interlocking, however, the machine will run although the guard has not been reinstalled or is improperly fixed. If the answer is no, that is, if access will be needed only for maintenance, repair, or remedy of rare faults, a third question must be asked. Will the hazard zone be accessed more than once per week? If the answer is no, a fixed guard is sufficient. If the answer is yes, a movable guard with interlocking must be installed. Remember the 3 determining factors for your choice: the general need for access, the reason for the access, and the frequency of access. Now we want to look at some of the general and basic rules for both fixed guards and movable guards. There are 3 rules for fixed guards. The most important is that they must be removable by use of a tool only. This is to ensure that removal is a deliberate action. Axelent X-Guard fence panels can only be removed with the special X key, a tool not found in everyone's pocket. Also, the guard should not remain in position when all fasteners have been removed. That is, a cover plate or mesh panel should fall off the machine. Of course, this must not present a hazard. Some guards are large and heavy enough to injure a person when dropping onto a body part. Such guards should be supported somehow and have handles for safe removal. X-guard fence panels tilt and slide to the floor, but will not fall off the posts. The third rule is somewhat strange. The fasteners of the guard must remain connected to the guard or the machine when the guard is removed. That is, you need to use so-called no-loss fasteners. 3 possible solutions are shown here. A clamping element, as on X-guard posts, a circlip securing the bolt, a quarter-turn sash fastener. But you may wonder, what is the reason for this strange rule? Well, when fixed guards are removed and the bolts are taken out, then these might disappear. One might be put in the pocket of the technician. One might be put in his toolbox. Another might drop to the floor and roll underneath the machine. When he tries to refix, he will use just those bolts that he still finds. After removing and reinstalling a guard several times, there may be no or little fasteners left. Then, other things are used to fasten it. Many, for instance, use tie wraps or twisted wire or some kind of bolt or screw that they just find, that they have on hand. Then the guard is not properly fixed. And finally, after some time of this practice, the guard may not be reinstalled at all and the danger spot open during operation. That's not what we want. So we want and need to ensure that the bolts, that the fasteners, remain either on the guard or on the machinery. Let's now look at some rules for movable guards. Movable guards take the shape of flaps and lids, sliding hoods, or doors, hinged or sliding. There are 3 basic rules for movable guards. It must be possible to open them without using a tool, for instance by pressing down a door handle. They shall remain fixed to the machine when open, which is achieved by hinges or a sliding rail. And most importantly, they must be interlocked with the machine's function. What does that mean? Interlocking guards have 2 main functions. They prevent start when open, and they cause stop upon opening. To achieve that, one needs a door safety switch that monitors the open and closed position, telling the machine what the state of the door is. And there is an important additional requirement. Closing of the guard must not directly start the machinery. After closing the guard, the operator must take action to start the machine willfully. In most cases, he will press a start button. In large integrated manufacturing systems, 2 willful actions must be taken before restart. A reset button must be pressed, and then the start button. As you will have noticed in our little animation, there is a downside to interlock guards. They can be opened while the machine is running. That can cause considerable trouble inside the machine, with parts just stopping anywhere. Even worse, the operator might still be able to reach moving parts and get hurt. How can we prevent that? We can use something called guard locking. What is that? A guard locking device is a special door switch that prevents opening of the guard while the machine runs. If the operator wants to enter the machine, he must first request unlocking by pressing a button. Then the machine stops and after that unlocks the guard. To restart the machine, the operator reverses the procedure. He first closes the door. Then he presses the reset button to lock the guard. When the guard is locked, he can press the start button. Only then will the machine start running. When deciding for an interlocking guard that allows opening the door during operation or guard locking, 3 questions should be asked. The first question is, will the machine continue to run for some time after a stop command has been given? If the answer is no, an interlocking guard is sufficient because no moving or hazardous parts will still be accessible when the door is opened. If the answer is yes, ask a second question. Will opening during operation cause trouble? If the answer is no, an interlocking guard is sufficient. But if the answer is yes, you should ask a final question. Will a hazard continue for a time that is longer or equal to the time required to access the hazard zone? If the answer is no, process-related guard locking is sufficient because safety is not a concern. However, if the answer is yes, a safety-related guard locking switch must be installed. Fixed, hinged, monitored or locked? What is your guard to be? Let me repeat some of the main points to take away from this webinar. Permanent openings in guards should be as small as possible. Remember 2 limit values. 120 mm is the maximum for slotted openings, and 850 mm is the arm reach distance. Fixed guards are meant for infrequent access after the machine has been shut down. They must not be removed more than once a week. That means they can only be used for maintenance access or when larger repair is required. Removal of fixed guards is allowed with tools only. Movable guards are meant for frequent access, but they must be either interlocked or guard locked. Interlocked means the machine will stop only after opening the guard. That means hazardous moving parts may still be reached after opening, if stopping them needs some time. Guard locking means the machine must stop before opening of the guard is allowed.
Thank you for joining this Axelent Safety webinar. You are invited to now ask your questions directly or send them in to safety@axelent.com. Have a good time and strictly no accidents. Bye-bye.